Okay, Professor Jim Schultz here from my Finance 680 students. As we talked about in class last night, I guess, since it is Wednesday, I wanted to go through number 31 from chapter 7. I wanted to make sure I put together this video going through this problem. This is an absolute beast of a problem. You've got quite a bit going on, and so let's work this guy out and go step by step and kind of talk through how you would solve this problem. Now, I don't have the problem itself up here. This is just my solution, so I'm going to kind of work through my solution. But it might help if you crack open your textbook and you have the problem in front of you, because this problem, basically, you have two different bonds. You have bond M and you have bond N. And essentially, all the heavy lifting in this problem is bond M, as in Mary. Because bond N is actually just one lump sum at the end. And you're going to notice that we actually find the value of N while solving for the value of M. And so, really, the bulk of what you want to do here, the meat and potatoes, is all in bond letter M. And so that's what we're going to spend most of our time on in this problem. Now, if you read through this problem, you notice that this is a 20-year bond with a $20,000 face value. And then essentially, you have kind of a weird payment stream where for 6 years you don't get any payments, for the next 8 years you get X, and then for the final 6 years you get Y. And so essentially what you have is you have three different annuities. Okay, with the first annuity being represented right here, whether it's an annuity at 0. But I like to, just for completeness purposes, include this in here. Now, one thing you'll note is, well, two things. I have the three different annuities stacked on top of each other. And again, this is, as I often say in class, this is not the only way to solve this problem. But I think it makes a lot of sense because it segments things clearly, and then you simply aggregate your results at the end to give you the answer that you're looking for. So that's the first thing. The second thing is this. If you look at my timelines, you will notice, like, look at the first one. It says there's no payments for the first 6 years. But you'll notice I have 12 tick marks. That's because if you read through the problem at the very end, it says that the required return on these bonds is 7% compounded semi-annually. So that is essentially another way to say that the coupon payments are being made semi-annually. And even though in this problem it doesn't say the coupons are semi-annual, we know, well, actually no, it does. It says the payments are made every 6 months. And so you have a compounding frequency lining up with the payment frequency, so you're all set. Don't need an EAR or anything like that. So that is why each one of my timelines is segmented into 6-month tick marks, not annual tick marks. Okay, so this one, essentially, we don't have to do anything with this first timeline because nothing occurs. The real work begins with the second timeline. All right, so the second timeline says that the bond's going to pay $1,100 every 6 months over the subsequent 8 years. So that is obviously the 8 years following the first 6 years, right? So that is why you see, starting in the 13th period, right? This would be 6 months into the 8th, or 6 months into the 6th year, and then for 8 years after that, so from 13 to 28, you're going to get $1,100. Now, one thing that I think is kind of interesting, and you'll see this over here with this n equals 16. 13 to 28. You have to keep in mind that over an 8-year period, there is 16 6-month periods, right? So that means if I start at 13, if that's my first payment, I have to end at 28. Now that may look like 15, but if you actually count them, like literally take your fingers and count them, 13, 14, 15, and so on, you will see that 13 to 28 is actually 16 periods. And so you certainly have to make note of that. I think that's one of the trickier parts of this problem in terms of setting things up correctly and understanding, you know, the time increments and the time dimensions and where you are at in the problem. All right. So what I'm going to do is, for a moment, I'm going to pretend like this isn't even here and this isn't even here. I'm just going to work with this guy. So I basically have an $1,100 annuity that occurs for 16 periods, and I want to find the present value of this annuity. Right now, I say the present value of this annuity at t equals 12. I'll explain that in a second. So the work is right here, right? The future value is 0. I is 3.5 because it has to be 7% semi-annually. You get $1,100 every 6 months, and there's 16 periods. You crank that out, you get $13,303.53. Okay, that is the present value of this annuity. But that number, if I had to put this number on the timeline somewhere, it would go at time equal 12. That's why you see PV of this annuity at time equal 12, because the annuity does not begin until time equal 13. So much like I think we've gone through this before in the first section of the class with time value money stuff, right? Think if you had a normal annuity, like a 2-year annuity, right? You got $100 for 2 years, so you had one payment, 2 payments. If I asked you to find the present value of that annuity, you would put your result at time equals 0, or 1 period before the first payment. So in this one, the first payment occurs at 13. So when you find its present value, it goes to it is situated at time equal 12. Okay. So what that means is you need to find the price of this bond. So you need to bring everything back to 0. Right? So that is why once you find this 13,303.53, you've got to now bring back to the present value at time equals 0. So your future value there, it's kind of difficult to see, but it's 13,303.53. Your I is 3.5. There's no payment because you've already accounted for all the payments in here, and you're simply discounting a lump sum back to the present, and you have to discount this bad boy 12 periods because, again, you're at this point on the timeline. So that gives you 8804.05. Okay, so that is essentially how you handle this second segment of the bond, and the final segment of the bond is going to be handled in a very similar fashion, right? This one you get $1,400 every 6 months for 6 years. 6 years is obviously 12 payments, and 12 payments, if you start at period number 29, is going to end at period number 40. And that should make sense to you logically too, that this problem would end at period equal 40 because it says it's a 20-year bond. There are 40 6-month periods in a 20-year time horizon. So this guy I did down here, the present value of this annuity at time equal 28. For the same reasons we saw up here, your first payment is at 29, so the present value of those payments goes back to 28. So that's tough to read. That is 13,528.67. Right? And so obviously the setup is pretty straightforward. Future value 0, I 3.5, payment 1,400, and 12. So once you find this guy, again, you've got to bring it back to the present value. So since you are at period 28, you've got to bring it back 28 periods. Payment 0, you've already accounted for them. I is still 3.5. Your future value is what your present value was here, and then the present value becomes 5163.28. And then finally, the final part is kind of tucked away in the corner. You still have this $20,000 lump sum payment occurring at the end that you do not see on the timelines. That's only because these timelines, I wanted to separate out the annuity portion and just handle the lump sum portion by itself. That would go here at period 40. So you've got a $20,000 payment occurring at the end, 3.5% discount rate, no payment because there's no reoccurring payment, right? That's what your payment key is for. Equal recurring payments, that's a lump sum, not an equal recurring payment. And you got to bring this guy back 40 periods. So that becomes 5,051.45. Now before I finish M, let me make a note of this. If you read through the problem, N is simply this. It's just a $20,000 lump sum payment at the end, and it asks you how much is that worth today. It's worth $5,051.45. So that's what I meant at the beginning of this video when I said while we solve M, we're going to find the value of N, right? So that is what I mean by this right here. So then to find the present value of M, you simply add up your 3 present values that you have correctly brought back to time equals 0, which will be this number, and this number, and that gives you $19,018.78. So this is how you solve problem number 31 in chapter 7. Definitely a difficult problem. If you can work through this problem successfully, then you have a pretty good idea, pretty firm handle on kind of a more sophisticated time value money application, right? I mean, I could have easily given you a problem like this back in chapters 5 and 6 and just not used bond terminology, just used basic, time value money terminology. So this is just kind of a sophisticated time value money problem, more so than it is a bond problem, but it definitely has bond characteristics with coupon payments and required returns and so forth. So I hope this video was helpful for you all.